Good morning, and welcome to the Ridiculously Early J Morning Show. My name is Michael. I'm your host, and today we're going to be talking about we're going to continue our series of building a presentation tool in J. I turn this off. Whoops, that's me. Sorry. Professionalism here. What you're looking at here is the tool that I build in this show. It is a presentation tool for making videos, interact or scripted video presentations about programming. On the left, you see an example of J code. This tool is written in J, and the presentations that I intend to make are generally about J, although I hope at some point this tool will be language neutral. So as you can see, J is kind of an unusual language. So I thought it might be interesting to stream some of the work I've been doing on this. So I'm here every morning on Twitch, and as well as I publish to YouTube, my YouTube channel. And for those of you who are only watching on YouTube or who are watching on Twitch, and this is a ridiculously early hour, I stream 8 a.m. to 9 a.m. Weekdays. I have also started on weekends and whatever time I have free to work on the code. I'm going to do that on a stream on Twitch, but without recording it, and not try to make it a presentation as these episodes are. Today is actually Labor Day, and I have the day off, so you can probably catch me later today on Twitch if you happen to be near a computer. Or I guess a mobile phone. You can stream on mobile as well. And feel free to come by, hang out, and just chat or ask any questions about J or whatever. Let's get back to actually. I wanted to say about that. I did that yesterday, and so I have. If you're watching this show and expecting a complete linear progression of every single line of code, that's not going to happen here. I'd rather summarize, because it takes sometimes a long time to struggle through some of the work. So I'd rather work on the low level details, off camera, and talk about anything important, when in summary. For example, today I am working on getting this part of the screen working. This is the REPL. It is a part where where I as the scripted presenter will be typing in text on the screen, and you'll see animations happening here of the typing, recordings of the typing, and then you'll see the actual output. So it is a read eval print loop for J, if you type this into a J interpreter, this is what you will get as output. And the idea is that I also want this kind of my first shippable product will be this little window as a standalone application that any J developer or anybody learning J can use on their own computer. That's what I'll be working on today. Let's see. Before I get into starting to get into the code and to doing a little code review of what I did yesterday. Which is actually very relevant to this object. I wanted to just say thank you to the arraycast podcast. So if you are a fan of J or interested in J or interested in array languages in general, these very terse notations for working with entire arrays at a time without having to write loops, there's a whole family of array programming languages out there, and they seem to be almost having a bit of a renaissance right now. Different communities are starting to come together. Part of it is very much thanks to the arraycast. I think this is a podcast created by a C++ developer who, Connor Hoekstra, I hope I'm saying your name right, who has gotten an interest in working with array languages, APL and whatnot. And so he's gathered this panel of people that are experts in the field on some of these different languages from different parts of the industry. And Bob Terrio was kind enough to mention my show on their show. So thank you very much, Bob, and thanks to the arraycast. This is definitely worth listening to. It's got a lot of interesting opinions. They do some nice interviews with developers in the language, Marshall Lockbaum, for example, and his BQN array language, and Henry Rich is the current maintainer of J. So it's a lot of interesting interviews, and also just like panel discussions about the array programming in general. The latest one was about tacit programming. So I did actually want to say something about that. I've been meaning to say this for a while. That some of the code, so tacit programming, if you listen to this podcast, you'll get quite an education about it. That's enough of that. Thank you. But tacit programming is very much this style of writing code without a lot of references to, these are functions right here. And this is code that does not make reference to the arguments of that function. In here, this particular function takes an array called y. This is an explicit definition of a function that manipulates a particular array and does this kind of cellular automaton thing called it's called a sandpile. It's called a sandpile cellular automaton, or the I guess a sandpile simulation. And these little functions these two functions together make the same. They do the same thing as this longer function here, and this is called a tacit style, where here we have we are creating an array. Well, first we're taking an argument that is always called y, and we're doing something with it, and then we are making some variations of this array, shifting it up, down, left, right, and so on, and we're using this is I'm making a variable called gt, and we're passing this to these expressions that are explicitly operating on these named things, and then actually creating nouns here. But in the future, in fact, the video I'm eventually going to publish is actually about how you convert this to this, and actually how you even start with this, and how you might start to think about this as a J developer. And so this is tacit style, and so so the arraycast is a good place to get started learning about that. And then there, of course, many of the array languages today have tacit abilities, the ability to write code like this, to compose functions in a way that you can build programs without having to write explicitly, to actually refer to variables and whatnot. But what I was going to say is that a lot of the code in this particular program is probably not a good example of that. This is probably, I would imagine this is the kind of code that people would be interested in seeing and saying, what the heck is that? How does it work? That sort of thing. And I have to admit that much of the code in my my application here does not follow that style, and that's because it's almost a little bit like Pascal's lament. The idea that I just haven't had time to make it short. And that is, it's certainly it's often the case that in J the shortest code is actually much faster than a shorter implementation is often much faster than a longer implementation, because the shorter implementation tends to be created by composing functions together, and those functions are all written in native code, and so there's not a lot of work for the interpreter to do. There's not a lot of string parsing and symbol manipulation for the interpreter to work on. Whereas if you write things in curly braces here, this is called an implicit definition, or this older syntax where we say define and then you have a end parentheses down here. These are parsed to strings, and then you have to build like an AST, and it's quite a bit more complicated than just looking at tokens and executing those tokens or composing those, the verbs associated with those tokens into higher order structures. So part of the reason that my code does not look all like this and isn't scaring everybody away is I'm writing what comes naturally to me, and what the first thing I think of. And sometimes I come from a background where I use languages like Pascal and Python, where they're quite a bit more verbose and imperative, and I do tend to take an imperative style, but it's actually leading me into some trouble. Because yesterday I was working on on, if I can find it. There's my terminal. I was doing some work on, well, on this thing right here, and as you know, the kind of the point of this REPL is it's nice and colorful. Jay has a REPL already, so why am I adding one? Well, one, so I can record it and make videos about it, but also so that it can be nice and pretty, and you can get these nice colors right there in the REPL. I've also, Jay comes with this idea called ViewMat, and it lets you visualize a matrix, and I have wrapped it so that it also shows up in the terminal. Well, in my haste to get something out the door, the way this works is a little bit clunky. First of all, I've got quite a bit of redundancy when I generate these little matrices. These are two Unicode block drawing characters next to each other, so we have a foreground and a background for each of them. And as you draw bigger and bigger examples of these things, my code does not take into account the fact that like two blocks next to each other might have the exact same color. And so, unfortunately, what it does is it prints out the full escape code sequence for each little block, both the foreground, the background, and the character. And those escape sequences can be very long. And so we're making the terminal do quite a bit of work. But it hasn't been a problem yet because I'm using tmux and putty, and these are, tmux is this program that lets you have multiple terminals embedded inside of one terminal, and then putty is the actual terminal emulator I'm using, and they're both very fast, and so I've been able to basically redraw this whole screen every time I press a key with no problem whatsoever. But there was a hitch there, because when I make these kinds of outputs from VM, what I was doing was I was having I generate all these redundant escape codes that generate the colors and whatnot, and I found that and as I said, they're extremely long, and they're extremely redundant, and it's simply generating a string, and then they allow this command generates a string, and this is what that string looks like rendered, but I was relying on the terminal to do the rendering, even within this application here. But the intent of my application framework is that we have a single in-memory buffer, a two-dimensional or a rank 2 array in J that contains the one for the characters, one for the background, one for the foreground color, and these three arrays model the state of the terminal at any given time. So once you have that, you can start doing nice things like saying, okay, only update the lines that have changed, since you can do some double buffering and be smart about it. Well, so yesterday, so up until this point in the stream, in the series of episodes, if you've been watching it, you might have noticed that this application tended to, as I paged through, it would tend to corrupt this side of the screen, and that was because as I was rendering this particular box, I don't have any way to parse those. I did not have any way to parse this output, and so I had to just store those strings and output those strings to the screen after I had rendered all the other stuff on the screen. So I would render everything on the screen, including the line down here that if I happen to be on this line, so that would get rendered, and then everything above this in this area was done after the fact, after the main render, and it was done by just emitting the strings to the terminal to let them cope with it. So I had this nice in-memory buffer that was blank up here, and then after I drew that, I would draw this thing. And that was actually working fine. It worked, but it wasn't what I wanted to do. And the problem was, because because this is output in escape codes, I had to parse the escape codes in order to rebuild I had to parse and interpret those escape codes in order to rebuild the in-memory representation of this. And so I had, maybe like a week or a couple weeks ago, I had sat down and just in one day I wrote a really scratch, ugly version of this, which again does not look like normal J code, but that is in vid.ijs, which is part of the JKVM, one of my dependencies, one that I am working on, which is a terminal library for J, keyboard, video, and mouse. And in here, so I have this rather unpleasant and long and unfriendly parser or state machine that lexes and interprets the tokens of an ANSI escape code or a extended ANSI escape code. And so this is really ugly code, and actually I plan to do an episode where I turn this into a much smaller system. J comes with a verb down here, this verb called sequential machine, which essentially allows you to make lexers and scanners, like tokenizers, that and potentially even like full parsers if you hook it up to something else. So I expect that I will be able to replace much of this with a few kind of complicated, some functions that kind of classify the characters, and then a nice state table. And I think it'll be very interesting to watch, because it's just that this is the sequential machine operation is actually a primitive in J, but it is probably one of the most complicated primitives in any language anywhere. It just takes it takes like 5 or 6 different arguments on one side, and it's not, once you get the hang of it, it's really powerful, and it can actually maybe even be in some cases faster or more useful than like using regular expressions, but give you that same kind of speed and expressivity. But it's something that is going to be fun to show off, and I think will be really interesting to watch. But I was lazy and I wrote it the old-fashioned way, just making a manual state machine. So as I said, like this is definitely a case where I haven't had time to make it short. And again, not just short, but fast. The shorter, I would expect that when I sit down and do this, we will see a dramatic improvement in the speed. And that's important because as of yesterday, it used to be that I could page through these things, and I've let go of the keys, and it would basically come to a stop within a fraction of a second, maybe half a second or so. And now I'm at the point where first, this is generating these extremely redundant escape codes to generate the picture. Then I've got this extremely slow parser to parse those escape codes. And then when I render it on the screen, it's generating another set of those extremely slow and redundant escape codes. And so now, between that 3-step process, I hold down this key for a second, and now I can take my hands off, and I can wait. I can probably go get a cup of coffee before this finishes. No, it's not quite that bad, but it does take quite a bit of time to draw. So that is definitely something that needs to happen, and happen soon. So if you're looking forward to if you're coming here looking to see some very, very terse and dense code, you might not see it today, but that's definitely something you're going to see here on the stream in the future as I start cleaning this up. Okay, so I think that actually brings us up to date. That is what I wanted to talk about. The one benefit of doing this is that now all of this is stored in a buffer, and I'm no longer screwing up the left and right hand sides of the screen. It's all a widget. It all lives inside of my framework, and I don't have any weird hacks like drawing ANSI codes directly to the screen after I rendered everything. So everything fits nicely in the widget framework now, and we'll clean it up in the future. But my goal is and has been for some time to get this working to the point that I can get a video out the door. And so a scripted video, where actually this video, it's something I promised over a year ago now, and I want to make sure that happens. We'll see some of those larger changes in the future. I've also got I also have like quite a small backlog of bug fixes and enhancements that I think are really easy. And I was kind of wondering, for those of you learning J or interested in this stuff, like would it make sense to make these into like bugs or tickets up on GitHub that and then you kind of ask people for help and say, hey, kind of mark these up as something that I think are really easy for beginners to do, and then give you guys the chance to chip in and work on something productive in J. If I don't know if people would be interested in that, so if you're here on Zoom, if you're here on Twitch, leave a comment or in the chat, and if you're on YouTube, leave a comment and let me know what you think about this, because if you would have any interest at all in helping with this, this is a passion project for me, so I'd be more than happy to help mentor an easier way through learning J in exchange for some help on this. This is all stuff that I'm going to get to at some point in the future, but if anybody else wants to take a crack at that, I would be more than happy to help with that. So let me know what you guys think about that idea. And also, anytime you leave a comment, you ask questions or whatever in the either on YouTube or on Twitch, and I'll respond if I can. Okay, enough about that. Let's do some code. So yesterday I was able to turn this REPL section up here into a widget. So this is now it's actually two widgets. We've got the history, and then we've got the single line that is actually editable. So there's two parts to it. Let's see. I said let's do some code, and then didn't write any code right. But if you press I think Shift E at the moment is bound to this. Yeah. So we have this editor that is actually not hooked up to the syntax highlighting, but I have another version of this that is. And so I want to kind of, in fact, I have a little bit of a redundancy here. I have this MJE application that's kind of my prototype, and then I've started working off to the side on a file called repl.ijs. And also forgot to say that if you want to know what the code is, you can look for yourself at tangentstorm/jpres. I was thinking maybe at some point I should go through and like tag these with the make some tags that indicate the episode of the show that that corresponds to that version of the code. But I haven't done that yet. Maybe I'll start doing that in the future. But in any case, you can find the code here, and this most of these files are not quite as pretty as I like, because I'm kind of like getting things working here, and then as I have the need to refactor and whatnot, I'll pull it out and move it to JKVM, which is more of a reusable framework for doing anything with the terminal, making terminal applications. Okay, so this is REPL. And I've talked about it in other episodes. In fact, Friday I spent quite a bit of time, even more than the 20 minutes I've spent so far, talking about basically the design of this and this widget. So I actually feel like that was one of my best episodes. It's kind of the most interesting stuff in it, even though it's not quite, maybe not the most array vectory language stuff. It's kind of got the most interesting model, because it's the idea of this time traveling REPL where it actually records the state of everything at every step. So that is in worlds.ijs, and my goal today is to get this worlds.ijs, the part that actually does the execution. It's doing execution. It's doing some small transformations that change. You can read about it here. That's changing the special names so that they work correctly. It then evaluates the individual strings, and it builds up this history. So we've got a history of the input, a history of the output, a little bit like a Jupyter notebook. And then with the addition of a separate namespace inside of the J interpreter for each cell in the notebook, so that we can so that as I'm so that I as a author of a screenplay here, a video screenplay, I can go back and forth and change something and go back in time and change how things would have been. but also so that people actually using it can experiment and if they type the wrong, you get a typo in J, you'll be able to press a key and undo the command you just entered. Assuming it doesn't like overwrite some files or anything like that. So that's what we're working on, and that pretty much that the logic is all there. Everything works. We just have to get it on the screen. So when I run this program, that's actually over here. It's running right now, and we have this single line input here at the top. We've got the the J, syntax highlighting. Ooh, that's pretty. Looks like there's a bug if you if you don't have a properly formatted J code, then I guess I need to fix that. Actually, let me make a bug report right there. Yeah, crashes your whole system. So if I just type open print, okay, so open quote crashes the. That's actually urgent. That's not a small bug. That has to be done right away. Open quote crashes the REPL. So we'll make that. Now that's going to be some work in the lexer. So I will. We'll see. We'll see how. Actually, I probably can fix that right away, because normally you're lexing. I bet if I say this, try this is the hacky way to do it. We won't try to recover the highlighting for the other tokens catch, but just so it doesn't crash on us. And we'll just say put s of b instead. So go xy 0 0 and put s of b. So and I think that will catch that error and. Yeah. So if we don't have syntax highlighting set up, or if we don't have a valid J statement, it will just remove all the syntax highlighting for now. That's not the right way to do it, but it's a quick and dirty hack that will let us get through the thing without crashing. So let's just commit that right here in JPrez in REPL IJS. REPL quick hack to cope with lexing errors. Lexing error on bad input, on unfinished input. Okay, and then let's see what I've changed here. Oh, and so this is what I did yesterday. You can see where previously I had this function called draw app that would render the application and then manually draw the history to the terminal after all the work with the buffers had been done. So that has now been replaced with new code that simply I actually just moved that code into the render now, and now that I have the ability to use put s or to put a string to my terminal and parse the VT escape code. So that gives me the 24-bit color and all that. So. Right. So now that's the change I made yesterday. So I'm going to go ahead and commit this. So MJE parse VT 100 codes when for REPL output for REPL history. Both the input and the output use these codes. And I think I might not have. Given that I didn't check that in, it makes me think that I didn't check this in. So vid.ijs. Diff. Git. Diff of vid.ijs. I did check my code in yesterday, but I had one extra bug fix. So vid.ijs. This is fixing a bug where. It was removing the first token because I had this. Redundant behead here. I have a behead in the definition where I'm saying basically just print anything that isn't print everything up to the first escape code after after breaking the input string on the escape code, the CSI, the sequence, the character sequence that you use to trigger one of these escape codes. So it's the escape and then the left bracket. And I was beheading it twice. So I defined chunks without the head, and then I came back and I had this bug where I was taking the first chunk off again, and so I had a bug where I was losing the first character of all my or the first token of all my output lines. And I also had a temporary bug there where I was dumping some junk to the screen. So remove. I didn't cover this parser at all in this in this stream so far. So if you don't know what I'm talking about, don't worry about it. This is just a parser for ANSI code or escape codes, and like as I said earlier, I will do a deep dive into this in the future when I port it to a better representation, probably the J sequential machine operator. So vidIJS bug fix for missing first tokens in output. Okay. I keep saying I'm going to start writing code, and then I don't write code out. All right. So anyway, so here's the code. Oh, I did write I did write some code today. Okay. So we've got this working. And now what I need to do is the very first thing I want to do is let's see. We have this thing called ed is this widget, this UI edit widget, and then we're superimposing this other toked widget on top of it to get the syntax highlighting, which is kind of explains what's happening here. So if we fail to render TED, then we just write over it with the buffer, the buffer that we're editing. So now we need to have a handler for what happens when you press enter. So what that means, let's see. The way that works is when you press enter, there is, so I'm going to call it like accept. Accept is going to be the verb that we use. Accept a line of input. Handler for, or event handler for accepting whatever the finished input. Okay. I don't always like Emacs's choice of indentation style. Let's see. So what we're going to do, I think eventually I'm going to have a widget called REPL or something, and this will be a method of that REPL. But I also think that widget will contain the line editor and the token editor for me. So the J code is going to be, I'm going to pretend that we're now inside of this REPL widget that does not yet exist. This unified REPL widget that does not yet exist. So source is going to take the buffer from ed, okay, and I already have a way to execute it in worlds. So I want to input worlds. By the way, I haven't mentioned this, but this whole idea of multiple worlds of saving the state every time you change, that came from this Ometa system. It's a tool for writing. It's this guy's PhD thesis, but it's also a language for writing languages, and you can kind of bootstrap it in pretty much any language you like, including J. And I've done some work in that direction. But he had this idea of making his parsers undoable, of handling backtracking by doing all of his assignments in these namespaces that kind of sprout up on the fly. And so I've mirrored his approach in Worlds here. Yeah. All right. So exec is what I want. So I'm going to use this world system as well. I need to initialize it, and so that's going to wipe out any namespaces that exist that use this world prefix, and set a counter. And then every time I run exec, it's going to. I believe it actually takes the. Do I have history in here? No, I don't have history in here. All right, so I'm gonna have to factor out some of the work that I'm doing in the screenplay parser and unify it with this and just put it all in one place. Because ideally you would just pass this, so this is a kind of like a REPL history widget, and so you would just pass it. Hey, Jingo Ringo. How roughly did you implement the parser combinators? So I'm not using the parser combinators right now, but if you want to skip ahead to something I'll probably talk about, probably in a scripted video at some point. It's actually in a different repo. It's the repo I used to use, github.com, Sabrin, and it's it's B4. B4 is the name of a virtual machine, and you can ignore everything here. This is all, some of it 9-10 years ago. But if you go into the J directory, that's relatively recent, and that's actually where I started doing all this code, and I've moved pieces of it. At some point, I have big plans for this, so this will definitely feature on the show in the future. But if you look at parseco.ijs, you'll see the parser combinators, and I will cover that in another episode in the future. And these actually do. Also follow the Ometa system by Alessandro Worth, so you might find them interesting, and they've got some. The code here definitely is written in a very terse J-like style. It also uses a lot of gerunds and whatnot, but I'll cover it someday. But if you definitely want to load this file, and you want to examine the output as you want to see the output. And if you're interested in the combinator approach, the virtual machine itself is also written in a very combinatorial approach. That's I've got this microcode and this, the instruction set, except maybe for the actual interpreter. But yeah, I'll talk about that someday, and maybe later today in office hours or whatever. Okay, so let's see. Yeah, so in my parser here in MJE, which again is still quite a mess, I do org slide. So somewhere in here I've got the code that, yeah, right here. This is the code that is reading all of the lines that have the colon in front, and those indicate that it's code to be executed and fed to this REPL. And so this chunk right here. All right, so if it starts with a colon, then we chop off the colon, and then now we have that line without the colon. And then if it has a dot in front of it, that is going to be the editor macros that's going to be the code to indicate that I need to play a macro at that point in time and actually replay the typing. And then the next line after those will be a colon without the dot, and that will indicate that this is the final state of this is what the macro should have produced. And so that way, especially if I start referencing like other lines in the history, it'll act as kind of an assertion and a test on the like a unit test inside the screenplay. But so now that we know that this is a line to execute, this is the chunk of code that has to happen. And it looks like I'm storing a lot of that state, actually the history and the lines and whatnot in in MJE, and I believe now that needs to be encapsulated in this object, this REPL object I'm making. So what we've got is we've got I history. No, so the input history. This is the I line is the input line that we are currently looking at, that we're currently rendering. And then I guess I call this is the output history, the echo history. I don't know why I did call it O history. So we've got two separate notions of history, the input and then the output, and they should be the same length. So one input corresponding to one output. And then as that goes along, we have a new namespace created, and in that namespace, so we execute the line in that world, that namespace, and exec is the code we were just looking at. Yeah. So, oh wait, hang on a second. Yeah. Okay. So there, this is because of the way namespaces are named. At least at the moment, there can only ever be one of these REPLs running in memory at a time, and so world itself, the world namespace acts as kind of like a singleton here. So we do have kind of like one place of one kind of like singleton thing, and so exec world is the line to call, but we need to handle this history as well. So exec in the world namespace of that line should handle creating the new worlds, and then to handle the history, which we need for rendering, that needs to be moved into either the world notion. Let's see. Clearly, the worlds are working fine without this. So it seems like this is something that is really more about the display of the history and the ability to move backwards and forwards in it. So, do I even use this at all? It surprises me. I don't use this anywhere, I don't think, except as just a global variable that tells me, you know, what was the last world that I was in. Not in this one, but in here. What is the last world that I was in? World. Lowercase. Oh. I'm not sure why I did that. I don't know what this is for. It doesn't seem like I'm using it for anything. Oh. I see. So world is a list of worlds, and that is the same length as the history. No, hang on. Yeah. Okay. So, this is specific to my input stream. So this is not this is specific to the screenplay notion, where I've got an outline and basically it's to pick. Just to leave one, because as I well, hang on. It's the history corresponding to the length of the number of inputs. So this list should be the same length as the number of inputs in the history, and I need to pick the world out of that list so that I can, because in that world, in that world I store, so like in world 7, let's see, names, world 7, I store where the like how, it's storing how much of the history to display. Yeah. Yeah, so it's storing how much of the history to display. And I will need that if I want to implement undo. So at the point that I implement undo, I'm going to need this world thing. So this is important for undo. So let's see. World is used. Let's see, used to track map current view to world, so we can see history length. We can see the history's length at that point. Is it from hist underscore world, or no, from you know, hist 0, hist 1. It's hist L, hist length, history length 0 and history length 1 in I from world. Okay, so we can see that. All right, so I guess we can start with this. So first let's import world and then just run this line and let's see where we get. So when we exec, so echo world is also going to write it to, let's see, what does echo do? Echo outputs the, it appends it to the echo history. So we have input history, we have echo history, we have world counter, and then ihist. Where is ihist changed? Ihist is not changed here. Ihist is changed here. This can move here. So in exec, we're going to, so when we tell it to execute some string y, we're going to immediately append it to ihist. That should still work. Let me just double check that it works. You know, of course it doesn't, because it's y. Exec world line should do that same thing now. I line is never referenced again. So not important. And then ihist is never referenced again here, so that does need, that was referenced here, input history, okay. Ihist is never referred to again in that file. EH length. Okay, and so now this is the line that is taking the the length of the history, and then we're inserting. Oh, I see. So yeah, okay. So what this is doing, so this is the magic line, and when I do this, it's going to insert so let's go exec. So it's modeling the idea of what's being echoed, and so here it is echoing the input that I just gave it. So if you tell it I+1, it's going to echo I+1 to the screen because that's part of building the history. But it is not going to be syntax highlighted, and so if you want syntax highlighting, then we have to remember the original length of the history, and then we're going to color this. We're going to call this VT color toke line. Or toke is yet another module in the system. It is the same thing that is providing the syntax highlighting. So this is actually probably this whole step is going to be part of the REPL widget. And I think, so I can get away with this for now, and we'll just lose the syntax highlighting in the history, and then we'll come back and do it later. And probably, let's see. As I said, I've got like two, like this was meant to be just like let's see. This REPL file is kind of meant to be just a standalone version that just had the basics, just enough to put the REPL in it. I'm curious now. What my instinct is to make this just a standalone widget, a REPL widget, and then move all of the stuff from. So basically, put everything related to the history in here. Make this a single object with a single interface, and it kind of hides the fact that we have this actual editor and we have this actual token editor for syntax. But then we have a standalone UI app, and that this is a situation where in Python I would say something like, okay, if name equals main. And I don't think such a thing exists in J. Or if it does, I don't know how to do it. I don't know how to detect that we're running this as a standalone application. So, I mean, maybe I just don't need a standalone application. Make a second thing that has the standalone application. And make this the REPL widget, and then run REPL be a second thing for now. Let me think here. That would almost seem to indicate that I want a third file that has the REPL widget in it, or yeah, as I said, run the REPL. I'm going to do that. I'm going to make this. I'm going to say run REPL. I'm going to keep this to be the file for the widget. So this is now REPL widget, including history, history display. REPL UI widget. Probably does depend on all that. But it's going to be we're also, we depend on UI, so we have UI, so we're going to say co-class UI REPL, like that maybe. Yeah. Extends UI widget. But that needs to be in quotes. I don't like how that's all caps, so I'm going to call it like that, UI REPL. And then create is going to be the oh, that's awful. I have this horrible namespace kludging here. Okay, that's fine. Because what I will do is when it needs to talk to so this will not be render for ed anymore. This will be render for this widget. So now that I have this widget, I don't need to put these things in the global namespace. So TED can just be this, or the token editor. And this is a little clunky, but it's fine and it doesn't hurt anything. Equals. So these are going to be the same, basically saying that wherever I. Oh, hang on. This is going to change. So the location of these two things is going to change every time I render, because probably this will move down the screen, right? We'll start at the top and then we'll eventually have the line being down at the bottom, right? Or unless we just always start at the bottom. So yeah, this actually does make sense as part of either render or update. So we'll leave that there. It's not going to act on its own, so it doesn't need to be active. So we don't need an update method. It's just every time probably every time we press enter, this is gonna change. Actually, this can go in the constructor for now. So these two will go in the constructor. So initial position of input line of input prompt. And then do I need, and then actually, since we're calling render TED directly, that just outputs a line. It doesn't care where it is, so TED doesn't matter. But XY of ed does matter. Right, so when we render, now here we're creating an application that has that one object, but now instead we are co-current base. I'm going to get rid of this in a minute, but I just want this to work. So I make sure I haven't done anything. So now instead of ed, I want REPL I got a real mess to clean up here, having to do with the namespace in which I look up the keys. I think that the way to handle this is we say, I'm almost out of time, aren't I? Ed. Yeah, I feel like I've got some technical debt that is keeping me from cleaning this up nicely. I am out of time for today, but it is Labor Day, and as I said, I'm going to be doing some further streaming later in the day. So I'm just going to cut this off here, and then probably by the time that we resume in tomorrow's episode, I'll have a much nicer, I'll have refactored this quite a bit, and we can do kind of a code review. it really is time for me to think through how I want to structure widgets, and especially compound widgets like this, like that use other widgets. App was the UI app concept was a first crack at that, but this is not an app. This is just a compound widget. So I need to do a little more design work here, on the object-oriented design level for GUI stuff. So tomorrow, I think we'll have a pretty good. By tomorrow, I think we'll have a pretty good design. If you want to participate in that or hang out, I will be streaming much of the rest of the day here on Twitch. But this is the end of the ridiculously early J Morning Show. So thanks for watching. You can always catch my episodes on YouTube if you missed earlier episodes, and they are also on Twitch for about I think 14 days. So thanks, and I will see you tomorrow.